Hi, everyone. I'm just waiting to see everyone in the room. We have about 21 folks in the room right now, so just give me a couple of minutes and we will get started. Thank you all for being here. We have quite a number of people that have signed up for this session. And so just give me a moment as the room starts to populate. We have about 51 people that are coming in. We actually have over 100 people that have signed up for this session, and we're so glad that you're with us. Okay, just give me a moment. All right, so I think we've got quite a few people in the room. We've got about 55 attendees at the moment. We are delighted that you're with us. We do have a bit of a technical difficulty, so bear with us and be patient. Dr. Caplan is in New York City, and they are actually dealing with a windstorm, so he does not have access to internet. That said, I'm going to go ahead and introduce him. And we are going to wait for him until about 11:10. If he does not get on at 11:10, what we'll do is we'll postpone the session and we will send you all an email and let you know when we're going to reschedule. So I'm really sorry about this. But we'll get started and hopefully he can join us. But the issue is that there is a windstorm. I'm in upstate New York and we were promised a windstorm as well. It hasn't hit us as badly. I hope wherever you are, you're all well and safe. And so let's start, and we will see how far we'll get, and we'll just play it by ear. So welcome to the Online Ethics Center Spring 2025 webinar series, Bringing Ethics into the Conversation. My name is Azita Hirsa, and I'm a senior lecturer in the Industrial and Systems Engineering Department at Rensselaer Polytechnic Institute School of Engineering. And we're located in Troy, New York, upstate New York, and Albany, if you all know where that is. I teach courses in management of engineering and technology, ethics of modeling, engineering ethics, and professional development, technical issues and solutions. Additionally, I host the Leaders in Action conversations, serve as the immediate past chair of the Ethics Division at the American Society of Engineering Education, ASEE, and I'm thrilled to have been a webinar host for the Online Ethics Center, OEC, since 2023. The Online Ethics Center, hosted at the University of Virginia, is a comprehensive digital repository dedicated to ethics education in engineering and science. Beyond providing valuable teaching and learning resources, the OEC cultivates a vibrant community of faculty, students, researchers, and professionals engaged in meaningful discussions on ethical issues. So please check out our resources at onlineethics.org. Our webinar series explores engineering ethics within the interconnected realms of industry, government, and academia, the triple helix shaping technological and ethical advancement. I'm delighted to welcome back Dr. Art Caplan today for part 2 of his thought-provoking discussion on ethical issues on the frontier of organ transplants. Dr. Caplan captivated us last spring. Now he's back to dive even deeper into the ethical challenges shaping the future of organ transplant. So I'm going to check back in here. He's not here yet, so I'll go ahead and introduce him, and then we'll see, whether he can join us. If not, we'll end today, and we'll send you a date as to when we're going to have this session for you. So I apologize, but the gods of weather have control over a lot of things these days. All right, Dr. Art Caplan, Doctors William F. and Virginia Conley Mitty, professor and founding head of the Division of Medical Ethics at NYU School of Medicine in New York City. Prior coming to NYU School of Medicine, Dr. Caplan was the Sidney D. Caplan Professor of Bioethics at the University of Pennsylvania Perelman School of Medicine in Philadelphia, where he created the Center for Bioethics and Department of Medical Ethics. Caplan has also taught at the University of Minnesota, where he founded the Center for Biomedical Ethics, the University of Pittsburgh, and Columbia University. He received his PhD from Columbia University. Dr. Caplan is the author or editor of 35 books, over 860 papers in peer-reviewed journals. His most recent books are Vaccination Ethics and Policy with Jason Schwartz and Getting to Good, Research Integrity in Biomedicine with Barbara Redman. He has served on a number of national and international committees, including as the chair of the National Cancer Institute Biobanking Ethics Working Group, chair of the Advisory Committee to the United Nations on Human Cloning, chair of the Advisory Committee to the Department of Health and Human Services on Blood Safety and Availability. He has also served on the Presidential Advisory Committee on Gulf War Illnesses, the Special Advisory Committee to the International Olympic Committee on Genetics and Gene Therapy, the Special Advisory Panel to the National Institutes of Mental Health on Human Experimentation on Vulnerable Subjects, the Wellcome Trust Advisory Panel on Research in Humanitarian Crises, and the co-director of Joint Council of Europe-United Nations Study on Trafficking in Organs and Body Parts. Caplan has served since 2015 as the chairperson for the Compassionate Use Advisory Committee, COMPAC, an independent group of internationally recognized medical expert, bioethicist, and patient representative, which advises Johnson & Johnson's Janssen Pharmaceutical about requests for compassionate use of some of its investigational medicines. Dr. Caplan is a regular commentator on bioethics and healthcare issues for WebMD, Medscape, WGBH Radio in Boston, WOR Radio in New York City, and KNX CBS Radio, Los Angeles. He appears frequently as a guest and commentator on various other national and international media outlets. Dr. Caplan is the recipient of many awards and honors, including the McGovern Medal of American Medical Writers Association and the Franklin Award from the City of Philadelphia. He was a USA Today 2001 Person of the Year and was described as one of the 10 most influential people in science by Discover magazine in 2008. He has also been honored as one of the 50 most influential people in American healthcare by Modern Healthcare magazine, one of the 10 most influential people in America in biotechnology by the National Journal, one of the 10 most influential people in ethics and biotechnology by the editors of Nature Biotechnology, and one of the most 100 influential people in biotechnology by Scientific American magazine. During the COVID-19 pandemic, he co-directed an advisory group on sports and recreation for the U.S. Conference of Mayors, created a national working group on coronavirus vaccine challenge studies, developed an ethical framework for distributing drugs and vaccines for J&J, helped develop rationing policies for NYU LMC and many other health systems, was a member of the WHO Advisory Committee on COVID, Ethics, and Experimental Drugs and Vaccines, and helped set policy for WRB, WCCG for research studies. He was an advisor to Moderna, Accenture, and he continues to serve on the NCAA Sports and COVID Committee. He received the Patricia Price Brown Prize in Biomedical Ethics for 2011. In 2014, he was selected to receive the Public Service Award from the National Science Foundation, National Science Board, which honors individuals and groups that have made substantial contribution to increasing public understanding of science and engineering in the United States. In 2016, the National Organization for Rare Disorders, NORD, honored him with their Rare Impact Award and Food and Drug Law Institute's Distinguished Service Leadership Award. In 2019, he was honored by the Food and Drug Administration's Reagan Ewald Foundation with its Innovation Award. NYU Rory Myers College of Nursing and Humanitarian Award. He holds 7 honorary degrees from colleges and medical schools. So our plan is to, or typically for those of you that may be new to this site, what we usually do is we have, oh, there's Dr. Caplan. Oh my goodness, you made it. We are thrilled to have you. I just finished introducing you, and I'm so delighted to have you join us again. It's just an honor to be in your presence and learn from you.
I have a question. Do you have my slides?
Yes, I do. Yep, I
Can
have
you
the
run
slide.
them? So I don't think I can share them. You can.
Yeah, absolutely. So I will
Okay.
share them in a second. But what I wanted to, in fact, I just finished reading all your accomplishments and I am just in awe. So what I was actually about to tell the audience is that what we typically do is after your talk, we will take questions. To ask a question, please type in the Q&A box at the bottom of your screen rather than the chat box, and I'll read your questions to Dr. Caplan. Audience members will not be able to use their mics and cameras. So with that said, I welcome Dr. Caplan, and I'm going to see if I can share your slides here. Let me just, give me a second, and done. I just need to make sure that we can share these in a mode that can be visible to everyone. One second. Okay. What do we think? We got it?
I see it.
Awesome. All right. So just let me know when you want me to switch and we'll do that.
All right. Well, thank you. Sorry to be late. Just having an internet issue up in Connecticut where I live. Just a big windstorm today. So it's my power and everything is fine, but something must have hit the tower where the cell service is, the internet service. Anyway, if I disappear, my apologies, but so far I got back, so that's good. I'm going to talk maybe 30 minutes, try to leave time at the end for questions or comments. Um, the topic is really sort of advances in transplant. And before I get into the pigs, which is a big advance, I just wanted to say a few words about transplantation more generally, not using slides. First, many of you know that transplants are very common in the United States. We can transplant kidneys and lungs and livers and hearts. In recent years, maybe starting 6 or 7 years ago, we also began to transplant what are called external organs, or sometimes referred to as composite allografting. It's just a fancy word for saying transplanting multiple tissues from different systems all at once. And that would be hands, which have skin and nerves and muscle and bone, faces, you probably have heard. The uterus has been transplanted now in women, some born without a uterus, to let them have a baby. And those transplants are much newer, but are also getting established quickly. So the first transplant that was ever done of anything was in 1954, a kidney transplant done in Boston at the Mass General Hospital. And that particular transplant was done between identical twins. They were people who, one brother was in failure, kidney failure, and we didn't even have machines at the time like kidney dialysis to clean the blood artificially. So people were desperately looking for something to do when your kidneys failed, you were going to die. And scientists, Joseph Murray and his team in Boston and others around the world had been trying animal experiments, and they finally felt like they could at least try a transplant in a human under very narrow circumstances. So To try a transplant in 1954, you had to have someone who was biologically identical to the donor. The reason is blood differences in types of blood type and immune system differences, antibodies, would lead the recipient's body to reject and kick out any transplanted organ. So you couldn't try to do a transplant from a stranger to a stranger, or even necessarily people who were somewhat related, like a cousin to somebody else. Their biology was just too different. Our immune system is pretty sensitive to trying to attack things that don't belong there, that come from somewhere else, whether it's something we ate or an infection that gets into us, like the flu or COVID or whatever. It tries to kill those things, and it would try to kill a transplanted kidney too. But if you're an identical twin, your biology is the same, right? You're basically uh, same blood type, same tissue type, and same size. You don't have to worry about fitting a big kidney in a little person, that sort of thing. So that's what they decided to try. So the first thing to keep in mind is, for transplants, if there are biological differences, you have to overcome them. And one trick later that emerged, and you'll see it in the history I'm going to tell you about in a minute about xenotransplant or using animals, was to come up with drugs that would tune down or turn off the body's immune system. Steroids are a version of that, but we have much fancier drugs now that we use to shut off the recipient's rejection immune system, so it doesn't reject the kidney or the heart or whatever's being transplanted. That's good news. Bad news is every one of those drugs leaves you open to infections because you shut off your immune system. You could die of athlete's foot. You could die of any infection that gets into you. So people on immunosuppression, you may remember during COVID, and even now today in flu season, you always have to wear a mask. If you've got a transplant, you don't like to go in big groups of people because you might catch an infection. So you don't want to get any infections if you have a transplant, because you are on medicines every day the rest of your life that shut off your immune system so your body doesn't attack the transplanted organ. So that was a big hurdle to overcome. Again, way back in 1954, this transplant between two identical twin brothers, you also needed to have them in the same place because no one knew how to transport an organ. So the things you see on medical TV shows, dramas, they get the little freezer and they're running out to a jet and flying the organ somewhere else. And they didn't have any of that. They didn't know how to use a freezer or a cooler. They didn't know what chemicals to put in the cooler to preserve the organ. So another requirement was, if you were going to try a transplant at that time, you had to be literally next to each other. The organ wouldn't live, and organs don't live outside the body more than minutes because they don't get any blood flow, they don't get any oxygen, and they die. So physically, transplant wasn't really too easy to do. It was limited to identical twins who were next to each other, not a big population of people. We didn't see many transplants done. But obviously, doctors and scientists and engineers were desperate to try and expand this capability to transplant organs to more than just identical twins. So at one end of bioengineering, people began to try and design drugs that would turn off or tune down the immune system of the recipient. And like I said, steroid drugs turned out to do that somewhat. That's, by the way, one reason you have to be careful if you're a bodybuilder. You don't want to take too many steroids. It makes your immune system weak. You may look strong, but you're biologically vulnerable. And another generation after generation, another drug called cyclosporin and a bunch of others that you don't have to know the names, but better drugs were tested, developed, tested in animals, tested in petri dishes to see what they would do to tissue samples. And that form of bioengineering led to the breakthroughs that allow us to transplant say, a stranger's kidney to somebody else. Remember, I mentioned that cooler. That's a bioengineering breakthrough, figuring out what temperature to put organs in, what do they have to be maintained at, what do you perfuse, or what chemicals do you put around the organ to help preserve it but not damage it so that it won't work. Another delicate problem. You got to get that exactly right. But bioengineers worked on that and came up with the coolers and the solutions to run through the organs that allowed us to preserve them at least for hours. That also required a different kind of engineering approach, getting airplanes and people from where the organ might be available to where the recipient was. So that became a helicopter aviation. You may not think of it this way, but at my medical school at NYU, we have a gigantic helipad. We started using it to bring in people who were injured in car accidents, maybe out far away from New York City, and bring them to the hospital. But pretty soon we realized we had to deploy the helicopters with the right coolers to go get organs and bring them back to us. The other big change in the history of transplant, everybody who was donating organs in 1954 was alive. And the only organ you could ethically take was a kidney. Couldn't take a heart, you'd kill the donor. We had to have some way to move beyond living donors because the only thing you had there was kidneys because there are two of them, and people basically believed that it wouldn't hurt the donor to live with one kidney. By the way, that's still somewhat controversial today. Living with one kidney is more risky. Obviously, if you get an injury to the remaining kidney, you're in trouble. And some people get diabetes, and that can really damage your kidneys. If you have two, it's better than one to get through a disease like diabetes, which is very nasty to kidney function. So people began to think, where else could we get organs? One place they thought about was dead people. They thought some people die, say, from a massive head injury. They get a gunshot, they have an accident, something falls on them. But the rest of their organs are in pretty good shape. It's just that their brain has been so damaged that they're dead. So here's a place where bioengineering, medicine, and ethics all had to come together. The old way to pronounce somebody dead was when their heart stopped and they didn't breathe. That was true for centuries. That's how everybody understood death. Your heart isn't going to work anymore, and your lungs aren't going to breathe for you anymore. That certainly is, today still, a way that most people are pronounced dead. But if that state happens and your heart stops, that means all the rest of the organs aren't getting the oxygen, right? There's no blood flow, and they start to get damaged very quickly inside the body. So people began to wonder, maybe we could come up with a second approach to death, and that is when your brain is destroyed, totally doesn't work. No sensations, no input, no communication. Somebody who has a massive head injury, you know, they're not going to be able to go on. If you could maintain a person after that terrible situation of brain death long enough to take their organs and remove them once they've been pronounced dead, then you might be able to get them less damaged and start to transplant them to somebody else. If you could put them in the container and preserve them pretty quickly, maybe you could fly them a couple hours to someplace else, or maybe use them locally, put them in some kind of an ambulance or state police and have them driven in the cooler somewhere. On the ethics side, we had to change all the laws to recognize that brain death, some of you may have heard that term, it's when the brain is totally and irreversibly destroyed, is equivalent to heart-lung death. If that's true, then people could say, well, if I'm dead, I want my organs to be used if someone else could benefit. And that became the ethics reform to create the Uniform Anatomical Gift Act, which you know today is the thing on your driver's license that says when you go get it, I want to be an organ donor. And we've actually now computerized that, another bioengineering feat, so that it's pretty quick to look up who's an organ donor when somebody dies. When you have that merger of medicine being able to do the transplant and tune down the immune system, medicine and bioengineering being able to transplant organs from one place to another using the cooler at the right temperature and chemicals to preserve the organ without damaging it, and an ethics bioengineering medicine collaboration, which says there's a different way to understand death. Brain death is, we can figure it out. We can see when the brain has stopped working. But if the rest of the organs are not damaged, if you choose or volunteer after your death to say, yes, you may use my organs, you consent to it, that's the ethics reform, then we could remove the organs while they're still in pretty good shape, put them in those coolers, figure out how to transport them quickly to a place where recipient is who needs it. And that became the modern form of organ transplant as we know it. And Azita, I'm going to just stop here to see if anybody has a question just about that basic background of how transplant works. But I know this is a group that's very interested in bioengineering. I wanted to point out this isn't just some doctors doing this. If you don't have bioengineers, both in pharmaceuticals to design the drugs that will shut off the immune system, if you don't have bioengineers working to develop the coolers and the chemical solutions to move the organs around, and to figure out how to do a transportation system with helicopters that won't that'll work quickly and not let the organs get damaged, and figure out how are we going to figure out whether the brain has stopped working by measurement of its electrical activity so we can pronounce brain death. You don't have transplant. This is, I sometimes laugh and say, this is one of the classic areas where medicine, ethics, and engineering have to come together to produce what we now see. The other place that people were thinking about getting organs was animals, and that's what I'm going to talk about next. But let's just stop here and see
Yeah,
if
yeah,
anybody
that's
has
great.
a question.
Thank you for being so thoughtful. So Nick asks, what tools are used to determine brain death? How are they 100% sure?
Well, first, Nick, you definitely want to be 100% sure because people get a little nervous if they think you're going to take your organs out and you're not dead. So we call that the dead donor rule in ethics, that no one should ever try to remove organs from a person who's dying before they're dead. That you just can't break that rule. And that's one of the strong principles that has been in place, I'm going to say, since brain death, which really the idea behind brain death began to be developed as long ago as the early 1970s. So we do have an ethical prohibition. You can't kill somebody to get their parts. We use a variety of tests now to determine when someone's brain dead. You begin by saying, what's the nature of the injury? As I said, sadly, sometimes the brain is so smushed, you don't have to talk about it. You know the tissue's destroyed. I mean, it could be from a variety of reasons. Secondly, if someone goes without oxygen for a long time, maybe drowning or they're asphyxiated, somehow choked, whatever, their brain cells literally begin to die. And you can take a picture of their brain with a CAT scan machine and see the brain is shrinking in on itself. There's no error there. Nobody's ever woken up from that kind of situation. So, first, how is the brain injured? We know certain injuries are fatal. They just, you can't do anything about them. It's like saying somebody got guillotined, in the French mode of the revolution. They're not coming back if their head is not attached to their body, if their brain is so damaged by terrible injury, they're not coming back. It's the same thing. So there's certainty there. Secondly, some other people, a drug overdose, you're not so sure. People's brains look okay and they're still kind of there. So we have a series of tests that get done. some involve reflexes. If you lose your reflexes to heat, pain, we know that the deepest, most basic parts of brain function are gone. So you do those tests, seeing whether someone responds. They shine lights in your eyes to see if you're going to open and close uh, your eye in response to light stimuli. They do pain, literally poking you, and so on. And we do those over a period of 48 hours. If those look poor, you're not getting anything, then you literally do start to take a CAT scan of the brain, and you also have machines that measure electrical output. That's another way to do it. And then if your brain isn't working, you shouldn't be able to breathe unless you're on a machine. That's called apnea, like sleep apnea. And so what doctors will do is they'll have you on a ventilator because it doesn't look like your brain is powering your breathing, but they'll take the machine off and watch. And if you don't breathe, say for 3 or 4 minutes, they know you're dead, even though your brain is not visibly injured. So that's the ways in which it happens. It involves specialists, neurologists who do this testing. Have I ever seen a mistake in 40 years? Yes, I have. I have seen a mistake. One problem is with little kids, children, they're a little more resilient. And the area that's a little bit tough is when they drown in cold water. If they're in a lake in Minnesota, a lake in upstate New York, and they fall through, you have to be a little careful about brain death because those brains are a little bit more resilient. And sometimes you get function back when you wouldn't in an adult. Why that's so, I'm not 100% sure, but it is. And so once in, I don't know, 2 years, somebody say, oh my goodness, we declared this child dead, brain dead. And then all of a sudden we got activity back. So I'm always saying, look, be cautious with kids because if you know the cause of their apparent death, drowning is the big one, then you want to wait more, test more, don't do the things that you do with adults. But otherwise it has held up. I think we don't see cases where people have woken up or something or, surprised us.
Great. Thank you so much. Nick, thank you for the question. And Dr. Caplan, thank you for that thorough answer. Justin's got a good question. Why does putting an organ in a cooler prevent it from decaying? Are there no medical instances that had an alive person be harvested for their organ accidentally?
I'm going to say no to the live person. We have, again, a lot of protections. You have to consent as a living person. Your family is around almost always. Nurses are there who wouldn't permit somebody to take someone's organ if they hadn't really given their permission. There's a lot of paperwork that you have to sign. By the way, one other odd protection, somebody's got to pay for it, and they're not going to pay for it if they didn't have a clear consent. So the cost of taking the kidney out with the surgeons and flying it somewhere, these are insurance issues. Somebody is saying, okay, and the insurance companies are not going to pay for stolen organs. Now, there are countries where organs have been taken. That's called organ trafficking, where people are exploited. Uh, Eastern Europe has had problems, Egypt, Brazil, some other countries. They do take people. The women are usually, sadly, exploited for sex for money, sex trafficking. The men sometimes are used as unwilling kidney donors. Why isn't that a big problem in the US? Because we demand to know where do these kidneys come from. So if you can't certify, here's the consent and this is where the organ came from, then it's not going to get used. Other countries with less oversight and maybe weaker governments and a lot more corruption, you do see it.
Great. Thank you so much, Justin. I hope that answered your question. I don't have any other questions,
All
so
right.
with your permission, we'll go back to the slides.
So let's look at the other source that people have dreamed about, which is could we use animal organs to supplement human organs? In the world of transplant today, we don't have nearly enough human organs, even with living donors of kidneys and dead donors of hearts and kidneys and lungs and uh, uh, pancreas and other organs. There's huge waiting lists. I'm sure you've seen stories about this, that we just don't have enough organs. If you want to be a good person, I would be an organ donor. I would sign my donor card. I would get on the computer registry and motor vehicles and do it. The field, like many parts of medicine, it has its issues. Sometimes there are people who don't have enough money to pay when they need a transplant. And so there's slight advantages to the insured and the rich to get organs. But generally, it's a system I support. I'm an organ donor. I think I can advocate for that. That said, there are not enough organs out there because not enough people say they'll do it when they die. And even if everybody said they'd do it, there probably are still a bigger demand than we're going to get. So go back one slide, and here's the old dream in the modern times. I mean, a lot of people, by the way, tried moving some organs around in animals in the Middle Ages, but that didn't end well. So what we call the modern era of xeno animal transplant, that's Greek for animal, XENO. Early experiments were tried at the University of Mississippi. This guy, Keith Reemsma, tried to do chimp transplants. By the way, he used a chimp that was a retired animal from a circus to get a kidney out of the chimp. You can talk about the ethics of that. I don't know if that was the right place to go, but we can debate that another day. Anyway, it didn't work. The patient died 2 months later. These modern experiments, say in the 1963, 1965 era, again, they don't really have the right medicines to tune down the recipient's immune system so that they don't attack the transplanted animal organ. They were using chimps because they thought they were closest to humans. That's why they picked them, both in biology and size. And they thought, well, maybe using the steroids they had, and if we radiate the recipient and kill their immune system, we could make this work. But Reemston himself said, look, uh, this field of heterotransplant, or what he means animal transplants, will get abused. It's clearly something that in 1963 they weren't really ready to try. Go up to the next slide. Other people did try. Thomas Starzl, by the way, a very, very famous surgeon who pioneered liver transplants at the University of Pittsburgh, tried at the University of Colorado where he was. Nobody survived. James Hardy, another famous transplant surgeon, tried again. Uh, the chimp heart was proving to be too small, even though the animals sort of, if you take an evolutionary view, are close to us. They're small animals. A chimp might be 60, 70 pounds, maybe a baboon, 60, 70 pounds, but they're literally, the physiology is not powerful enough to power, let's say, a 110-pound female or a 200-pound male. So they were realizing the chimps maybe just weren't going to be the right kind of source, even if they could figure out how to get the recipient not to kick out a transplanted animal organ. And remember, animals are, no matter how close they are to us in evolution, they're more different than human to human. So that proved to be tough. Next slide. Very famous experiment was tried later in 1984 at Loma Linda University Medical Center in California. Very prominent pediatric surgeon, Leonard Bailey, decided to try to use a baby, infants born with malformed hearts that didn't work right. He decided maybe we could use a baboon heart to try and treat them. But his goal wasn't to replace the kid's heart. It was to hold the kid over until a human heart donor could be found. That's called a bridge to a human transplant using a, um, in this case, baboon heart. Go to the next slide. And baby Faye got tons of national attention way back then as the first baby to get a kind of baboon heart transplant meant to be temporary. There were problems with this. I will tell you, I was just getting into bioethics then, and I was very critical of what was going on here because there aren't any or many human baby heart donors. Babies don't wind up in car accidents. Babies don't fall in swimming pools. Babies, happily, they're not dying in ways that human donors do and could supply an organ. So even if you put this baboon heart in, I didn't think there was going to be a human heart to try it. And if you put the baboon heart in, you may have made the baby's immune system so mad and angry that it was fighting this baboon heart that it would reject anything else that you put in. That didn't seem to make sense. So early, meaning 1960 to the 1980s, efforts to use animals, they justified it by saying we don't have any other options. The baby was going to die. We didn't have a human heart to give to baby Faye, but maybe we could find one if we extended her life. The diseases were so bad they're going to die anyway, so why not try? That's what the guys in Mississippi, Colorado, and so on were doing. They had people were dying, and they said, "Well, try something." And so they tried to justify it, but they definitely didn't. Still found out they couldn't suppress the rejection of those animal organs. They were too different. In trying to do that, they opened up these people to infections. You may remember from the slide, a lot of them got pneumonia and other infections and died. That's because the immune system was totally shut off and they couldn't control it. Some of the animals actually have their own weirdo viruses. If you transplant using them, you're going to bring these viruses. Think about bird flu. Think about swine flu. These are things that are in monkeys and primates and baboons. They have diseases too, and you may be just bringing them in to an immunosuppressed human. They didn't know how to do that. Also, some people said you shouldn't be killing the primates. It's wrong as an animal rights issue to sacrifice chimps. They're intelligent. Baboons, pretty smart, maybe a little nasty, but sentient and pretty smart creatures. So there was a lot of protest from animal rights, basically saying there's a quote down at the bottom there from PETA, which was just getting formed at the time, People for the Ethical Treatment of Animals, a big animal rights group today. It's medical sensationalism. You're just showing off. You're looking for headlines. You want publicity. You're exploiting the animal and the family in a hopeless quest to maybe find some way to get through all this. And they basically were even saying the ethics is bad because the mom who consented to try this experiment on her baby was so desperate that she would have consented to anything. And if you didn't give her a good, clear explanation that there were a lot of things that could go wrong, and the baby might even suffer more than it would if it just died, then you didn't get a good informed consent. And one of the leading critics about that was me. So worried about the ethical problems around informed consent and using animals. Next slide. Everything shut off with animals after baby Faye. It was just like, we don't know how to do it. We're not sure what the heck is going on. The dream of using animals didn't go away, but it was the medical challenges, the bioengineering challenges that led people to say, we have to stop. And so for 20 years, at least, no, really more, 35 years, people just didn't try animals again. And I think in the interim, people also said, you know what, chimps, baboons, they're too small. They're not the right source. And there are people who say these are more sentient and smarter animals, and it is ethically disturbing to kill them to get their parts. And we don't want to do that. So the animal rights objection, I think, did hold weight with transplant teams. But as time wore on, people began to shift their focus, and guess what showed up in their sites? Pigs. Um, why pigs? Well, for one thing, there are a lot of them. We probably eat every year worldwide 2 billion pigs for bacon and sausages and pork chops and whatever. Secondly, pigs are about the size of humans. They're a couple 100 pounds. Their organs, people began to think maybe would sustain an adult, which primates are too small and probably wouldn't have the power to drive blood circulation or do the filtering of the body's waste that the kidneys have to do, and so on. So discussions began. Maybe we could do pig kidneys as a model. And that's what has now started to happen these days. And Azita, you can shut off the slides. I'm going to say a few more words about pigs and what's happening there. And then we'll really open it up for questions. So remember all these obstacles I mentioned. Well, one thing that's happened is we do have better drugs and we can fine tune them a little bit better. And that gave transplant people a little more hope that maybe we could not have to kill everybody's immune system to get an animal organ in there. We are transplanting very successfully, say, a Zeta's kidney to me, even though different genders, different blood types, different tissue types. That's working pretty well. Took us about 40 years to get the drugs right, but there it is. And so survival from a kidney transplant, a transplant team that doesn't get 10 years or more out of a kidney transplant is not a, they're not doing things well. I mean, they're going to get looked at by payers and so on as to why are your rates poor. So that's pretty good. I won't say that people who get a kidney don't need it replaced. It does slowly stop functioning as well because even though we like all the drugs, they're not 100%. And so things do begin to damage. But if you get 10 years, that's a pretty good deal, especially if you get it, say, at 55 or 60. It might even take you to the end of your life. Secondly, what else has happened since these days of baboons and primates and baby Fae and things that didn't work? Well, genetic engineering. So here comes the bioengineering part again. People start to say, hey, wait a minute. You know what we might try? Making pigs that are genetically engineered so that their immune system isn't as likely to trigger a response from the human recipient. And that is exactly what we're trying now. When you see the experiments with pig transplants, these are not pigs that are on a farm or a factory farm turning into bacon. These are genetically engineered pigs being taken care of very humanely, stress-free, optimum diet, great environment. It's true they get killed, but they don't suffer because no one wants them to have organ damage from stress or anything else, but they are specially designed, tweaking the genes in the pig embryos to try and tune down their immune system instead of trying to just tune down our immune system. In addition to that, we can now screen using genetic science for viruses that the pig might have. And so you'll see people say we screen the pigs for transmitting what are called zoonotic viruses that might harm the recipient, what I was talking about with bird flu or swine flu or whatever it is. And so we control for that. There are even people starting to try and do genetic engineering to kill any viruses that might be in these pigs. Long story short, I think pigs may turn out to be a supplemental supply. Progress is being made. We just sent home a woman from NYU with a pig kidney, 3 months out, surviving and doing well. Now, does that mean she's going to be able to go 10 years? I don't know. No one knows. But it's certainly better than being dead within 2 weeks, which is what the old models and the old pioneers had to try and contend with and gave up. So we're not giving up. Are there still animal rights issues? Yes. People would still say you shouldn't kill animals to try and save people. I don't accept that. I think if you can kill a pig to save a baby, I would do it. I'm not happy, but we kill 2 billion animals to feed ourselves. If you really want to reduce animal suffering, it's really on the food side that we should be going with pigs, not the medical side. Even on a good day, even if we made this work, we might use 5 or 10,000 pigs to get organs. I don't see that that's anywhere like what we could do if we became more vegetarian or improved how pigs are raised for meat, which is not good. They suffer. These animals don't suffer and they're treated well so that at least maybe it's wrong for them to be killed, but they don't suffer the way they do in a farm where they're crammed together and don't have any space and can't want it. These animals, they go where they want. I'm almost tempted to say they have a happy pig life until the day comes when they're going to be used. But again, suffering very much minimalized, partly for humane reasons, but partly for pure optimization of their health and the organs. And you don't want infections. You don't want them sitting next to each other, infecting one another, and all that sort of thing. Is it the long term answer? Last thing I'll say to needing organs? No. It's a bridge. We're going to use it for a while. The long term answer is to come up with artificial organs. That is a bioengineering thing. Make a kidney that you could wear, kind of like kidney dialysis. Come up with an artificial heart that you could put in. We don't have those yet. I don't think they're on the horizon for at least 7 or 8 years. We need more organs right now to supplement the human ones, but the supply isn't big enough. So I think you'll be seeing and hearing about pig organ transplants maybe another decade. Then hopefully bioengineering will step back in and say we can make these things, or we can use stem cells, those cells that turn into different cell lines, and maybe use them as repair kits to fix a heart that has damage from a heart attack or a liver that's damaged from alcoholism or whatever. We won't transplant a new one in, we'll just regrow the cells in the damaged organ. That's the future of bioengineering and medicine, is to develop those things. There's even 3D printing. Some organs lend themselves to that, uh, more the ones that are pumps or tubes like blood vessels, or the uterus, kind of making an artificial bag that within which you could grow a baby. They're further out, but yeah, that's a bioengineering solution that I think is coming. So I think pig organs right now, they're not ideal. You still got to use all these drugs and engineering. It's not an elegant solution. Be much better to have an artificial machine that could do these things or a repair kit that could fix things. That's more elegant, probably cheaper, less burden on the recipient than pouring all these immunosuppressants in and designing the pigs so that they don't trigger a rejection and making sure the pigs are, on and on. It's like there's a lot of rigmarole in there to get pig organs into people. Is it worth doing? Yeah, because you're saving lives that would be lost, but it's not the, many of you on the call are going to have to come up with the answers that are more cheaper and elegant, longer run than this. All right, so I'll stop there, see if we get any other questions.
Absolutely. So, right, I've got a few questions I want to ask you, but before I do that, I've got a quick question. What sort of information do we have in terms of which nations, what parts of the world are sort of doing the research on this? Is this mostly in the Western, sort of hemisphere? Is it United States? Where are we at? And in terms of sharing, how are we sharing this, kind of information across countries and border lines? Yeah.
Yeah, well, there are efforts to do pig organs, US, UK, but also Turkey has a program that I've seen. India has a program that I've seen. So I wouldn't say a lot of countries, but a few. I have asked religious leaders in Muslim
Mm,
countries and Jewish countries, would you use pig parts? And they
yeah.
said, look, if you could save a life, yeah. So there isn't really, they don't like you eating them, but they are a little bit more sympathetic. If it's life saving, they would
Mm,
allow you to overcome prohibitions that way. So I brought religious leaders together on the ethics side just to hear
mhm,
what
mhm.
they think. I would say the other sharing thing, not as good as it should be because a lot of people still want to be the first to make it work. Some of them are thinking, hey, maybe I could patent the genetically
Right.
engineered pig and sell it. Well, I'm not sure that's the best environment. I think you have to be a little more open about what you're doing so others can critique it and learn from failures. But it isn't as, there's not as much information exchange as I've been arguing for.
Mm. Okay, all right, excellent. Thank you. So Stephanie Bird asks, please discuss the challenges and obstacles to sufficiently informed decision making of both donors and recipients that's necessary for informed consent. And the second part, she'd like you to discuss informed assent versus informed consent.
Well, in the second one, informed assent, that's what we use primarily for children. And they can't really consent, but if you're like maybe between 8 and 12, maybe you can understand enough to give a kind of permission to get an animal organ. Flat out, we're not using any kids yet. It's too dangerous. It's too hard, and the physiology, trying to put again these organs that are large into littler kids right now. No, it'll happen, but we don't have. Nobody's using kids right now. I think everybody believes they should pioneer the danger in the adults first. Part of the reason is if the thing goes south and you die of rejection and so on, it's very miserable. I mean, you really suffer. So even though a kid's dying, you may not want to put them through that kind of a death. There are things worse than death. We could really up your suffering if a pig transplant doesn't work out. It's just not a good experience. So that comes back to the first part. So how do we get people to consent? Well, I think it's always ethically important to say, if you don't want us to use pigs, you can stay on the wait list for a human kidney, let's say. And then you have to explain to them what the odds are of getting a human kidney. They're usually, say, in New York at NYU, if you're on the wait list, you have about a 50% chance of getting a kidney in the next few years, and then you're probably going to die. We do have dialysis that can work for a while, but for various reasons, we can't keep you on it forever. And so you have to be honest. Some people then decide, well, I'd like an option. And you can say, we have the animals, but you have to be careful and say it's experimental. We don't know what we're doing. Literally, we're trying to genetically engineer the pigs and we're trying to give you drugs and we're trying to kill the pig viruses. And we just don't know. You're going into a big unknown. That knocks out a lot of people who say, well, I don't know. I think I'll take my chances hoping I get a human. You can also advocate for kidneys that someone look for a relative or a stranger. So people do go back to their church or their high school or their former boyfriend or somebody and say, would you give me a kidney? You see it doesn't work out so much, but they have to know all their options, what they could do. And then I've insisted that we appoint somebody who is just the advocate for the potential pig transplant, an advocate, subject advocate, because this is research. Their only job is to keep the potential person who might get a pig informed about all the risks and benefits, privacy issues, burden on the family to take care of you when you come home. What's that going to be like? Media attention. They want to write stories about you. Can you not do that if you don't want to be in the papers or the social media? So I'm big on a subject advocate that just works for the potential recipient. We use that model at NYU. Not everybody does, but those are some of the tricks.
Great. Thank you so much. So Shirkar asks, with all these ethical challenges mentioned, past and present, do you think that xenotransplantation, genetic engineering, could take off in the future, possibly with other animals?
Yes, it could. I mean, another animal that's got the right size are sheep. They're kind of big enough probably to support a human. I don't think we're going back to primates. Partly, as I said, still too small, partly on ethics grounds, too close. People really don't like killing chimps. And, the only primate that might make it to our size is probably gorillas, and we're certainly not going to be killing them. They're endangered. Plus, by the way, raising primates is a lot more expensive than raising pigs. So there's a cost thing that starts to get in. So maybe sheep or an animal like that, something that's the same size, but beyond that, no.
Hmm. Okay, great, thank you. So Jade wants to know, what do you think the line is between a transplant attempt that is a strong contribution to the research versus a transplant attempt that just causes more pain to the patient? How should doctors and scientists handle that gray area?
There's a lot to say about that, and that's a very good question. Just in the interest of time, I'll say two things. One, you must commit to publish. You haven't published from any experimental transplant team, whether it's a face transplant or pigs or whatever it is, then you have broken your promise to learn with the people that you've done these experiments upon. So you must publish in peer-reviewed journals. By the way, and that doesn't mean just standing up at a press conference and announcing something with no data and no paper, which some people do and I think is wrong. I think you got to have the data available and other people look at it and learn from whatever happened. The other thing I think is important is to maintain a registry. I've been arguing for a long time that everybody who does pigs should register their patients and their protocols, what they do, what drugs they use, the kind of genetic engineering in some database. So anybody, we could all go look at it if we wanted to and track and compare what's going on. So you need registries. We don't have them yet sufficiently, but we need them. And we need basically publication to occur in a speedy manner. If somebody said, well, what's that? I'm going to say within a year, you should have written up what you did.
Great, thank you. I want to make sure that you're okay. I know we're gone
I
about
can do another question, then I'll run off.
another question. Excellent, thank you. So is it solely up to the patient to decide if risks and benefits of receiving a transplant are worthwhile, or do physicians hold ultimate decision-making authority?
No one's going to make a physician do anything they think is too risky. So they do hold ultimate authority. If I came and said I have 5 different diseases, but my kidney's failing too, I'm probably not going to get picked for a pig transplant right now by the doctors. Are going to say that is too risky. And even though you want to do it, we're not doing it. So, and surgeons have a long tradition, by the way, of coming in a room and saying, I looked at Art, he's a mess, and we're not going to do any operation on him because he's too likely to die, and walking out. So there's a lot of authority on the surgical side of medicine. They make risk determinations a lot about what they're going to be doing. Um, they don't get, when you see these fights break out about, can we take a feeding tube away from someone who's severely brain damaged? Surgeons don't have those fights. They come in the room and they say, I'm not doing that. And bang, out they go. Different cultures. That's just history. The other part of it is there are committees that oversight, which I didn't get to talk about today, human subjects research ethics committees, also known as institutional review boards, and they have a say in whether something's going to be permitted at NYU or Mass General or Turkey or wherever it is. And they do. They sometimes may say, I don't think the team is right. You don't have the right expertise. We're not convinced that you know what you're doing. And even though the patient wants it and the doctor wants it, we're not going to approve it until you make changes. So there are other safeguards. It's not just what the patient wants.
Thank you. Thank you so much. I feel so much smarter every time I read anything by you or hear you speak. I think I'm gonna ask you to become a regular on here. So thank you for being so generous and sharing your time and your
I'm
knowledge.
glad I didn't disappear into the ether there, the internet.
Right. And it's funny because I said to everyone that there was a windstorm in New York City. I didn't realize you were in Connecticut. So I hope
Yeah.
everything will be better and you'll be safe and sound.
It's funny. I'm looking out my window. I look out on a big forest here. It looks calm now, so maybe it's over.
Oh, good, good, good. And I also want to thank OEC's director, Dr. Rosalind Byrne, and our coordinator, Tracy Marshall, and to all of you that joined us and those of you that asked awesome questions. I'm sorry we couldn't get to the last few, but thank you, everyone. Enjoy the rest of your day, and wherever you are, have an awesome rest of the week. All right, take good care. Bye-bye, everyone.